Hello everyone. I am Maria Angelique Gonzalez and I'm going to discuss the lesson 6, which is all about equivalence of parallel postulate. In this lesson, you will learn about the postulate in Euclidean geometry, called the parallel postulate. Equivalence of parallel postulate. Thousands of years ago, a Greek mathematician named Euclid laid out the foundations of plane geometry in 5 postulates, which are statements assumed to be true without proof. In today's lesson, we will cover his 5th postulate, called the parallel postulate. What is postulate? Euclid had many great ideas, but not all could be proven. A postulate is an idea, also called an axiom, that is taken to be true even without proof. Contrast a postulate with a theorem, which is shown to be true by using proofs. What are interior angles? Interior angles are the angles formed when a transversal crosses 2 other lines. The interior angles are between the 2 other lines. Exterior angles are outside the 2 other lines. Same-side interior angles are the 2 angles on the same side of the transversal. What is parallel postulate? A parallel postulate is if a straight line intersects 2 straight lines forming 2 interior angles on the same side that add up to less than 180 degrees, then the 2 lines, if extended indefinitely, will meet on that side on which the angles add up to less than 180 degrees. The fastest way to understand the parallel postulate is to set up some line segments. Use uncooked spaghetti. Take 2 strands and arrange them a bit apart from each other but leaning toward each other. Lay a 3rd strand across the first 2. You see you have created 8 angles at the 2 intersections. Look at the same side interior angles toward the close ends of spaghetti. The sum of both same side interior angles is less than 180 degrees, so Euclid is saying the lines represented by the first 2 spaghetti strands will, if extended, eventually meet. Let's draw the parallel postulate. Take a sheet of paper, pencil, and straight edge. Draw a short line, perhaps 10 centimeters long. Move away a few centimeters from it and draw another 10 centimeters line. Now draw a transversal line crossing both of those first 2 lines. If the 2 interior angles on the same side add to less than 180 degrees, the drawn lines will, if they continued, meet. Try it. See if they will meet. Now start again, but this time, draw 2 parallel lines. When you draw in the transversal, the 2 same-side interior angles will either be exactly 90 degrees or will be a combination of an acute and an obtuse angle. For any line and a point not on that line, Euclid shows us that only one line can be constructed through that point that will be parallel to that line. All other lines will eventually intersect with that original line. Euclid's parallel postulate allows that transversal to create many different angles as it cuts across the 2 lines, but it all boils down to only 3 possibilities. The lines are not parallel and 2 same-side interior angles are less than 180 degrees. The lines will eventually meet on that side of the transversal. The lines are not parallel and 2 same-side interior angles are greater than 180 degrees. The lines will never meet on that side of the transversal. The lines are parallel and any 2 same-side interior angles will be equal to 180 degrees. The lines will never meet. As long as the 2 interior angles on the same side of the transversal are less than 180 degrees, less than 2 right angles, the lines will meet. That allows the transversal to even be at a right angle to one of the lines, with the other line creating an acute angle. Such a situation will create a triangle of the 2 lines and their transversal, which connects directly to the Pythagorean theorem. If you hop over the transversal that created two interior angles less than 180 degrees, the other two same-side interior angles will always be greater than 180 degrees. No matter the combination of lines, transversals, and same-side interior angles, Euclid's parallel postulate holds true. Only in the special case of parallel lines will a transversal of any angle create four interior angles such that two same-side interior angles are equal to 180 degrees.